All right, Chapter 9, Section 6 deals with solving equations with square roots. So the first thing I'm going to do is just define what a radical equation is. So an equation in which the variable is in the radicand of a square root is called a radical equation. So what we're saying here is we may have an equation that looks like this, okay? And the key here is the variable is the radicand. In other words, it's underneath the radical symbol. So the question becomes, well, how do we solve this? Now, one thing we do have to be careful with. All right, so we got to be careful. When we write the square root of x and we're solving for it, we are using the property that the square root of x is, that the square root of x is greater than or equal to 0. Okay, we're just assuming that because we know I don't want to write that. We know a negative underneath the radical symbol, no matter what the number is, I'll just put the number symbol, is a non-real result. Okay, it's a non-real number. Okay, so if we write square root of x, we're assuming that it's going to be greater than or equal to 0, or in other words, 0 or positive. So the first thing I want to do is let's just start off with just a simple question, which is if I have an equation, are the following solutions x equals -2 or x equals 1? Are they solutions? So for the first, we're going to let x equal -2. So I'm going to rewrite the problem wherever I see the variable. I'm going to put parentheses first. Then I make my substitution. Let me zoom in here a little bit more. All right, so there's -2, here's -2. And my question is, does the left equal the right? Well, you have a double negative back to back, so that makes it positive. Okay, and 4 plus 2, oh, I don't know why I wrote 4. So we get 2 plus 2, the square root of 4, or it's going to be the square root of 4, and the square root of 4 is 2, which does not equal -2. So the answer is no for the first. Okay? Now I'm going to zoom out here a little bit, draw a line, because we got another one. We're going to let x equal, what is it, -1? No, +1. Perfect. So rewrite the problem. Wherever we see the variable, put parentheses, then make your substitution. So if I do the work underneath the radical, -1 plus 2 is +1. And the square root of 1 is equal to 1. So we would say yes. X equals 1 is a solution. So this is just basically just substitute. Tell me what it is. It's going to be a yes or no question. I guess if you guessed, you have a 50% chance of getting it correct. I don't like guessing. I like knowing. So just do the work. It takes you a couple minutes to do it, but easy problems to get correct. So now the question becomes, okay, well, in this example, I gave you answers, right? I gave you x equals -2, and I gave you x equals 1. What if I don't give you anything? How do we solve a radical? Well, here are our steps right here. So go ahead and pause the video and write them down. When you're done writing them down, unpause it, because I'm going to go over it. So to solve a radical equation, the first thing you're going to want to do is isolate the radical. Then you're going to square both sides of the equation. Step 3, you're going to solve that result equation. And then 4, you always want to check your answer. So what I want to do here, though, before I even do an example, is I want you to be aware of what's happening here, okay? When it comes to solving equations, prior to this class, you only knew how to solve one type of equation, and those equations were linear. Okay? And with a linear equation, there are those 6 steps, you know. Step 1, multiply by the LCD to get rid of all the denominators, combine like terms, parentheses, all that stuff, right? So now you know how to solve linear equations. But now we can extend this even further. Because we also know how to solve quadratic equations. You also know how to solve rational equations. And finally, what you're learning here are radical equations. Okay? So, like I said, prior to this class, the only thing you know how to do was solving linear. Now we have 3 other types of equations. So please, whenever you're given a problem, the first thing you want to be able to do is identify the type of equation. Remember, linear, the variable or variables, it doesn't matter, all have the exponent 1. That's how you know it's linear. Quadratic, one variable has the exponent 2. Okay? Rational, you have a polynomial over a polynomial. Okay? And then a radical contains the square root or some sort of root. It could be the 3rd root or the 4th root or whatever. Okay? But this is how we can tell what type of problem we have. So now let's go back and let's look at our steps and let's do an example, okay? All right, so step 1, we're going to isolate the radical, square both sides, solve the equation, check the answer. So here's a very simple problem. We have the square root of 5x minus 4 minus 9 equals 0. So right from the start, I can see a radical symbol. I know this is a radical equation then. So step 1, let's isolate the radical, which means this square root of 5x minus 4, I want it all by itself. So I have to take this minus 9 and add it to both sides. Then I have 5x minus 4 on the right hand or on the left hand side and a positive 9 on the right hand side. Step 1 is done. Step 2, we're going to square both sides of the equation, okay? So I'll just get out my red marker. I square both sides. Now, to be honest with you, the left-hand side is the easier of the two sides, okay? Because if you think about this, the square root of 5x minus 4, and I'm only going to write this once, but the square root of 5x minus 4 squared is really the square root of 5x minus 4 times the square root of x minus 4. In other words, just to make this look easier, it's like saying the square root of 5 times the square root of 5. We know that is really the square root of 25, which turns out to just be 5. In other words, it's the radicand. So on the left-hand side, you're left over with 5x minus 4. The right-hand side is actually the harder or the more difficult because you got to know what 9 to the second power is, and that's going to be 81. Now, we have a new equation. Notice the exponent. It's a 1, so this is linear. So I don't see any fractions. I don't see parentheses. I can't group anything on the left, can't group anything on the right. I'm just going to add 4 to both sides. That gives me 5x equals 85. And then I will divide both sides by the coefficient of the variable term to give me x equals 17. And before I go any further, I have to check my answer because I don't remember. You could get an extraneous solution here. All right, we were introduced into the concept of extraneous solutions in the previous chapter, so that could still apply here. So let's just go ahead and let's check it real quick. 5 times 17 minus 4 minus 9 should equal 0. All right, so 5 times 17 we know is going to be 85. 85 minus 4 is the square root of 81 minus 9. We know the square root of 81 is 9 minus 9 equals 0. So I feel good about this answer. I can square it, put a block around it, whatever you want to do. Call it a day. To be honest with you, that's as hard as it gets. You follow those steps, every single problem is done the same exact way. So let's look at another one here. How about the square root of 3p plus 3 plus 3 equals 5? Okay? So once again, it's a radical equation. So I need to get the radical symbol by itself. I need to isolate it. So I will subtract 3 from both sides. That's going to give me on the left-hand side the square root of 3p plus 3 equals 5 minus 3 is 2. Now I will take the square of both sides. So I'm just going to rewrite it here. On the left-hand side, I get 3p plus 3. On the right-hand side, I actually have to do 2 to the second power, which is 4. Now I will subtract 3 from both sides. That's going to give me 3p equals 1. And then finally divide both sides by 3 to give me p equals 1/3. Now, remember, check your answer first. So let's go ahead, let's check it. So I get, let's see, 3 times 1/3 plus 3 should equal 5. Now, underneath the radical, 3 times 1/3. Well, that turns out to be just a 1. So you get 1, or the square root of 1 plus 3 plus 3. Now, this 1 plus 3 is the square root of 4 plus 3. Square root of 4 is 2. And 2 plus 3 definitely equals 5. So I know this is a good answer. So I circle it, move on to the next. All right, so here's another example here. Okay, now this one, you got to be careful with it. So we're going to solve 2, or the square root of 2x minus 3 plus 5 equals 0. Okay, now it's a radical equation. I know I got to isolate the radical, so I will subtract 5 from both sides. That's going to give me the square root of 2x minus 3 equals -5. Okay? But here, we got to stop. Now, ask yourself, why do we have to stop? So if you need to, pause the video, then unpause it once you got your idea. We have to stop because the square root, remember, cannot equal a negative value. Can't equal a negative number. Remember, all the way at the beginning, I'm going to scroll up for us so you can see it. All the way at the beginning, we said that we got to be careful. Because when we write, sorry, let me fix this box here. Here we go. Oops. When we write the square root of x, we are using the property that the square root of x, whatever the result is, on the right-hand side has to be 0 or larger. Got to be a positive number. Okay? So that's what happened here with our problem. All right? This square root of 2x minus 3, it cannot equal a negative number. So you just stop. And you just say, non-negative result. Okay? Or can't do the problem. I'm sure WebAssign has something in there. I think it says, I think they want you to type in no solution. Okay? So you got to be careful with that. Now, these final examples here, we just got to be aware of what's happening. Okay? Because I see a lot of students will make this mistake. All right. So we're going to solve the square root of p minus 1 plus 1 equals p. Once again, it's a radical equation, so let's isolate it. So we'll subtract 1 from both sides. On the left-hand side, it's going to give me the square root of p minus 1. And on the right-hand side, it's going to give me p minus 1. Now, This p minus 1 on the right-hand side, that's fine. Because we don't know what p is, so we don't know if the right-hand side is going to be negative or not. So what we're going to do is we're just going to solve this problem. So we're going to square both sides. Okay? Now, you got to be careful on the right-hand side. The left-hand side is easy. The left-hand side is going to be p minus 1. That's good. It's this right-hand side I got to be careful with, because remember, p minus 1 quantity squared means p minus 1 times p minus 1, which means we have to distribute. They give us p squared minus p plus 1, or p squared minus 2p plus 1. So I need to write that over here. P squared minus 2p plus 1. Now notice here, this resulting equation, which step 3 is we got to solve, this is quadratic because of this term right there. It's not linear. The 2 dominates. So this is going to be quadratic. So we know we have to get it equal to 0. So I'm going to go ahead and get this thing equal to 0. Add 1 to both sides. So that's going to give me 0 equals p to the second minus 3p plus 2. And the reason why I got to get it equal to 0 is because to solve a quadratic, you factor. So 0 equals p minus 1 times p minus 2. Now, we set each one of these factors equal to 0. And solve them individually. So I get p equals 1 or p equals 2. Oh, and I did the bad thing. Sorry, I did the bad thing. I circled my answers. I don't know if these are correct because I got to check them. Remember, you got to check. So on the right-hand side here, let's go ahead. We're going to write the original equation. Square root of p minus 1 plus 1 has to equal p. So for the first, we're going to let p equal 1. Let's check it. So wherever I see that variable, I'm going to put parentheses. Then I make my substitutions. Put a 1 and a 1. So underneath the radical, 1 minus 1 is 0. Plus 1, square root of 0 is 0. And 0 plus 1 is definitely 1. So I know this is a good answer. Now I'm going to do the same exact thing with the number 2. So I put a 2 there. Remember, I'm going to erase the variables, replace them with brand new parentheses, make my substitutions. All right, so square root of 2 minus 1, well, 2 minus 1 is going to be 1. Square root of 1 is 1. And 1 plus 1 is 2, which is what it should equal. So I know this is good. Now I feel a lot better about myself. Okay? Let's look at another example here. Okay, how about the square root of x plus 4 minus x plus 2 equals 0. So we have to isolate the variable. Or I'm sorry, isolate the variable. Now I'm really getting ahead of myself. We need to isolate the radical symbol. So I will add x to both sides first. And then I will subtract 2 from both sides second. All right, so that gives me the square root of x plus 4 equals x minus 2. Now that the radical symbol is isolated, I will square both sides. Okay. On the left-hand side, that's easy. We get x plus 4. On the right-hand side, that's the toughie. So x minus 2 times the quantity x minus 2 is going to equal x squared minus, sorry, moving too fast, minus 2x plus 4 So that gives me x squared minus 4x plus 4. Okay, I notice quadratic, so I'm going to set this equal to 0 and go ahead and solve. So I subtract x from both sides. That's going to give me 4 equals x squared minus 5x plus 4. Subtract 4 from both sides. That gives me 0 equals x squared minus 5x. Go ahead and factor. I got a GCF. 0 equals x times the quantity, x minus 5. And then I just set each one of these equal to 0. Oh, I did it again. I got x equals 0 for one solution, or x equals positive 5 for the second. But I got to check myself. So I'm just going to rewrite the original problem. Square root of x plus 4 minus x plus 2 equals 0. We're going to let x equal 0. And remember, the goal is so that when I substitute in 0, I get 0 as a result. So 0 plus 4 is the square root of 4. Minus 0 plus 2, well, that's just plus 2. So the square root of 4 plus the square root of 2 is going to be, let's see, 2 plus 2. And 2 plus 2 is 4. And 4 does not equal 0. So cross it out. That's extraneous. Okay. Now we're going to let x equal 5. So let's do this all over again. All right. So let me go ahead and substitute in a 5. All right. So 5 plus 4. Well, that's going to be 9. Minus 5 plus 2. Square root of 9 is 3. Minus 5 plus 2. 3 minus 5 is negative 2 plus 2. And negative 2 plus 2 is 0, which is a good thing. So the only solution is x equals 5. So like I said, you got to be careful with this. Okay? Let's do one more like this, and then we're going to switch it up a little bit. How about 2 times the square root of 4a plus 2 minus 16 equals 16? Once again, you see the radical symbol, you got to isolate it. So I will add 16 to both sides. That's going to give me 2 times the square root of 4a plus 2 equals 32. Now I will divide both sides by 2. And the reason why I'm dividing both sides by 2 is so I can reduce the 2's on the left-hand side. Because remember, I want this radical isolated. So I have the square root of 4a plus 2 equals 16. Now I will go ahead, square both sides. On the left-hand side, I get 4a plus 2. On the right-hand side, I'm going to have to bust out my calculator. 16 to the second power is 256. Now this is linear, so I go ahead and subtract 2 from both sides. I get 4a equals 254. And then finally, I divide both sides by 4. 254 divided by 4 is actually an ugly number. 63.5. So what I want to do is just reduce this real quick. So a equals 127 over 2. But remember, we got to check it. So let's see, what was the original problem? 2 times the square root of 4a plus 2 minus 16 has to equal 16. So if we're correct, We should get 16, so let's see. 2 square root 4 times. And you know what I'm going to do? Hopefully you can see this. I'm going to use this result right here. 254 over 4. Instead of the completely simplified version. And the reason why I'm doing that is hopefully you can see I have a 4 in the numerator. Let me highlight it here for you. 4 in a numerator, 4 in a denominator. They're going to reduce. And that's really what I want. So I just want them to reduce. So that's going to give me 2 times the square root of 254 plus 2 minus 16, which is 2 times the square root of 256 minus 16. Now, the square root of 256 is 16 minus 16. 2 times 16 is 32 minus 16, and 32 minus 16 equals 16. So I know they're good answers. 254 over 4 reduces down into 127 over 2. So, hey, I'm sorry, it's not the prettiest answer out there, but it's the correct solution. So now what I want to do is just transition, because sometimes you may run into this situation right here, okay? You may run into this. The square root of 4x minus 3 equals the square root of 3x plus 2. Notice you have a radical on both sides. But if you think about the first step, isolating the radical, look, it's already isolated. You have 2 of them, but they're on opposite sides, which is great. So all we have to do is square both sides. That's a beautiful thing. Now, this is really nice because the square root of 4x minus 3 squared is just 4x minus 3. And the square root of 3x plus 2 squared is just 3x plus 2. Now, it's linear. All the variables are raised to the first power. So I'm going to subtract 3x from both sides. That gives me x minus 3 equals 2. I'm going to add 3 to both sides to give me x equals 5. Remember, you got to check. So 4 times 5 minus 3 should equal the square root of 3 times 5 plus 2. Well, 4 times 5 is 20. 20 minus 3 is the square root of 17. 3 times 5 is 15, and 15 plus 2 is also the square root of 17. So, on the left-hand side and the right-hand side, you get the square root of 17. So I know that's a valid answer. Okay? Now, there may be other times where instead of having a square root on both sides, all set up nice and neat like this, you see how they're nice and isolated, you may run into this situation here. Okay, now this example, we got to be careful because although it looks like the same as above, in the previous example, meaning that you have a radical on the left and a radical on the right, I just want to be a little careful about how we do this because here, I'm going to give you a little hint, okay? Let's put a little star. You want to isolate the more complicated radical. Now, what I mean by more complicated is if you compare these two, you have the square root of m, and then you have the square root of m plus 9. This one on the right-hand side is the more complicated one because you got to do m plus 9. Like, you got to know what m is, and then you got to add 9 to it, and then you got to take the square root. Whereas on the left-hand side, you don't have to do all that. So what we're going to do is I'm just going to rewrite the problem. And then I'm going to isolate the square root of m plus 9. So I will add 1 to both sides. So that's going to give me the square root of m plus 1 equals the square root of m plus 9. Now, the reason why I wanted to do that is because step 2, when we square both sides, on the right-hand side, we get m plus 9, so it's already simpler. And on the right-hand side, remember, we have to actually distribute all that. So I'm going to just draw like a little line right here. put the square root of m plus 1 quantities times the square root of m plus 1 inside of a quantity again. Now when I go ahead and multiply, I'm going to distribute. So I get m plus the square root of m. And then I will go ahead and distribute the 1. So I get the square root of m plus 1, which gives me m plus 2 square roots of m plus 1. And that is what we write over here on the left-hand side. So you do have to be really careful that you don't rush through these, okay? All right? So now, if you notice, I got another radical, which means I got to isolate, and that's fine. So I'm going to go ahead. I'm going to subtract m from both sides. That's going to give me 2 square roots of m plus 1 equals 9. Then I will subtract 1 from both sides. They give me 2 times the square root of m, which equals 8. And since on the right-hand side, that's like a nice number, and what I mean by that is I can divide both sides by 2 to give me the square root of m equals 4. And then finally, from here, I will square both sides of the equation again to give me m on the left and 16 on the right. Now remember, you got to make sure that 16 checks out. Okay? So let's go ahead. Let's write the original equation, which I already forget what it is. Where is it? There it is, all the way up there. So let me write check. All right, so we're going to have the square root of 16 has to equal the square root of 16 plus 9 minus 1. Well, square root of 16 is 4. On the right-hand side, 16 plus 9 is 25. The square root of 25 is 5. And 5 minus 1 is definitely 4. So I know m equals 16 is a good solution. All right, so I want to do just one more example here. It's basically going to be the same setup as the previous problem. So we got the square root of m plus 5 equals the square root of m plus 16. All right, so I got 2 radicals. The one on the right-hand side is the more complicated one, and it's already isolated. So I'm just going to go ahead and square both sides. On the right-hand side, that's nice and easy. You get m plus 16. But on the left-hand side, we got to be careful. So let me zoom out. Let me write it. Square root of m plus 5 times the square root of m plus 5 again. Now we're going to go ahead and distribute. So that's going to give me m plus 5m. Oops, sorry. Plus 5 square root of m. And then I'm going to distribute again, but this time I'm going to distribute the 5. So that's going to give me plus 5 square roots of m plus 25. All right. So that's going to give me m plus 10 square root of m plus 25. So I'm going to write that on the left-hand side. M plus 10 square root of m plus 25. All right. Now we're cooking with gas. So now I got another radical. I'm going to go ahead and isolate it. So I will subtract m from both sides. That's going to give me 10 square root of m plus 25 equals 16. Now I will subtract 25 from both sides. So 16 minus 25 is going to be 10 square root of m equals negative 9. And from here, I'm just going to stop. And the reason why I'm stopping is right here. I'll highlight it. You got a radical, and we know radicals cannot equal negative numbers. So we stop, and we write no solution. Okay? So that's going to be it for this lecture video. If you have any questions, feel free to email me. Other than that, good luck. Remember the steps. Isolate the radical, square both sides, solve the resulting equation if possible, and then lastly check. Good luck on your test. I'll talk to you later.